Problem number 98. If the characteristics equation of a 3 cross 3 matrix is lambda power 3 minus lambda square plus lambda minus 1 equals 0, then matrix should be, we have four options: Hermitian, unitary, skew symmetric and identity. This is most important conceptual problem. Let us see. Given is, we have our characteristics equation lambda power 3 minus lambda squared plus lambda minus 1 equals 0. Now we simplify. We take lambda square as common, then we left with lambda minus 1 plus we take 1 as common, it will be again lambda minus 1. Now we can take lambda minus 1 common, it will be lambda square plus 1 equals 0. Now we equate A and B as 0. Now we equate lambda minus 1 as 0 and lambda square plus 1 as 0. Here lambda minus 1 equals 0 means lambda equals 1. Lambda square is equal to minus 1 and then lambda is equal to plus minus 1 can be written as I. Now we have our lambda value as 1 plus I and minus I. Now we have to check options. First we check identity matrix. Identity matrix, let us take for example a 3 cross 3 identity matrix. From properties we know lambda is equal to 1 1 and 1, which means identity matrix do not contain negative lambda value, so identity matrix is ruled out. Now we check for option C, which is skew symmetric. From properties we know eigenvalue of skew symmetric matrix is always either purely imaginary or 0. That is, lambda has no zero in it. It only has imaginary, as lambda is equal to 1 is neither 0 nor imaginary. Now skew symmetric is ruled out. Now we check for option. Now we check for Hermitian, option A. Eigenvalues of Hermitian matrix is always real. as lambda equals I minus I is not real, but lambda is equal to 1 is real. But we have I and minus I, so Hermitian matrix is ruled out. Hermitian matrix is ruled out. Now we are only left with one option, which is unitary. From properties, we know eigenvalues of unitary matrix is always unit module or unit length, or we can say modulus value is 1 or length 1. So lambda is equal to 1, I and minus I, they all have unit length. This has unit length 1, this has unit length 1, and this has unit length 1. Length here means if we take square root of 1, 0 square plus I square is equal to under root I square, which is equal to I, and I is equal to 1. So finally we can say eigenvalue of unitary matrix lies on unit circle, and eigenvalue of unitary matrix is always on the boundary of unit circle. Now we can say option B correct.